chemical, thermodynamics. The physical and chemical changes are usually accompanied by energy changes. Everything involving change of energy. Everything. Among the various modes of transference of energy heat, light, mechanical energy, electrical energy, etc. are quite important. All these energies are convertible and are related to each other. Quantitatively. the study of the flow of heat or any other form of energy into or out. Into means just coming inside. Out means going out. Out of a system. As it undergoes a physical or chemical transformation is called thermodynamics. So this is the definition of thermodynamics. When it is involved in a chemical reaction or chemical process, we call it chemical thermodynamics. Chemical thermodynamics deals with the energy changes involved in chemical transformations. These energies may be in the form of heat, light, mechanical, and electrical energy. Thus, chemical thermodynamics deals mainly with the study of these forms of energies and the quantitative relationship between them, particularly for chemical systems. Okay. So this second paragraph is the definition of thermodynamics, and third para is the definition of the chemical thermodynamics. So anywhere energy involvement is there. Energy involvement. When you study this energy involvement and their interconversions between them, that is called thermodynamics. So now we are using electricity. For using electricity is being converted into what? Is being converted into light, is being converted into heat, is being converted into sound waves. So these are all nothing but the thermodynamics, the interconversions. Good. Now we should know that what is the purpose of studying thermodynamics. The human beings do not do anything. It is if it is not useful to them. Otherwise, they will not do it. There should be some utility. Okay. Anyway, somehow it is being missing from your book. So we're going to discuss the objectives and scope of thermodynamics. Objectives and scope of thermodynamics. Okay. So, one. See, it tells us whether a certain process, whether it is a physical or chemical process, is going to occur or not. Initially, everything, when the inception of the universe, people have learned everything by trial and error, out of inquisitiveness. They tried, something went, something did not materialize. Now, if you want to start anything in a physical and chemical process, sitting in front of a computer, you can do it. Okay? Because if you know the concept of thermodynamics. So, one, it tells whether a particular physical or chemical change can occur under a given set of conditions of temperature, pressure, and concentration. Second, it also helps in predicting how far, means how much you can achieve, how far a physical or chemical change can proceed until the equilibrium conditions are established. Third, so there are various laws up there in physical chemistry. Earlier, people used to explain only by the words. So they used to line by line, which leads to a lot of confusion. Now this can be proved even by mathematically. The moment it's done mathematically, then you are satisfied. And you know it is a factual truth, because mathematics is not a fiction. Various laws of physical chemistry, including vapor pressure, phase rule. These are some of the rules that you will study. This was there in your syllabus, that is being removed, but class 12 will study. And the distribution, that you have no scope. Distribution law is there in BSc law, can be derived from the laws of thermodynamics. So these are the objectives. This is the way it helps us. Okay, but it has lot of shortcomings also. Demerits also are there, that I'm also going to write. First you write this one, then I will write. Please give me 2 minutes. I'm coming. Have do some more. Okay, now let us see the limitations in where we cannot apply thermodynamics. Limitations of thermodynamics. See, thermodynamics never tells us what is the type of the system that we are taking, whether it is gaseous, solid, or liquid. It does not give any direct information about the nature or structure of matter. Thermodynamics says the feasibility of a process. It says that yes, if you want to carry out a chemical reaction or a physical process, it is possible. But they do not tell us that how much time is required for it. Will it be a short duration or is it going to take an infinite time? It does not. Okay, I will write in a little better way. Though it predicts the feasibility of a process, but fails to give any information about the time required for it. That is, it does not predict the rate of change of the process. Third, see, thermodynamics does not give any importance to the state of the matter. It only considers that it is the matter which carries the energy. Okay, suppose we want to do some work. So in that process, if we engage some people, so we are not interested about the people. We are only interested about whether they are doing the work or not. In dealing with thermodynamics, matter finds no consideration except as a carrier of energy. Okay. See, thermodynamics laws are applicable for large amount of substance. We call it macroscopic substances. It cannot be applied on a single atom or single molecule. The law of thermodynamics apply on the matter in bulk, that is macroscopic system. And not an individual atoms or molecules of the microscopic system. To learn some words or terms which are used specifically for thermodynamics. Okay, so now we are going to discuss about it. These words you are using in your day-to-day life, but you do not know where from it has come. Some basic terms and concepts of thermodynamics. Okay, so let us write here first. Say it is a system. See, it is the area of our interest. Okay. See, suppose you are moving around, suddenly you will find that your eye has catched a certain object, and you are started of following it or observing it very carefully. Okay. It may be an object near to you, or it may be as far as like a star. So that we are going to call it a system. System can be very minute or system can be as large as universe. But mind it, wherever a system is there, suppose you paid your attention here, but this one is found in a place. Okay. So if you are interested here, then this is system. Then what is this? This is what we always use in your day-to-day discussion. We call it surroundings. So it is system and this is surrounding. Now, the system is being separated from the surroundings by a imaginary boundary, imaginary line. Because if you are looking at the sky for a particular star, you cannot go and put a circle around it. Okay? You cannot put a circle around it. But suppose you have taken a cup of tea, that the tea is inside the cup. This tea is being enclosed in a container. Okay, so it is a reality. So in that case, this type of line which demarcates, it may be an imaginary or it may be a real line which separates system and the surrounding is called boundary. So what is this? This line is the boundary. The boundary can be imaginary or it can be real. So let us write system. A specified part of the universe which is under observation is called system. Then the remaining part of this system is called surrounding. The remaining part of the universe which is not a part of this system is called surrounding. Okay, then what I can say? If I add system and surrounding, what I'll get? So if I add here system and surrounding make universe. See, it is the science or the thermodynamics which has made our heart very big. Though we pay attention to the nearby object, but you do not forget the object around it. Okay? So make your heart as big as universe. In that case, you can understand the beauty of this universe. We will not demarcate or differentiate people, whether it is a male or female. We will not differentiate human being, whether he is Christian or Muslim or or Hindu. We'll treat them as one. We are not going to differentiate human being on the basis whether they are staying in hills or plains. Who is tribal, who is non-tribal, not like this. You will find if you can overcome this small barrier, there's a lot of happiness in this world. Okay? We only differentiate. See, already our earth is being separated into continents by the sea and the ocean. Land is being separated by international boundaries. And human beings are being separated by religion and the language we speak. Forget. Okay? And you'll find you can make friendship with anyone, you can learn anyone's language. We will appreciate each other religion. Okay? You'll make your heart big. Whole world is now being separated on the basis of religion. So much of fundamentalism is coming up, and the worst affected in the process of fundamentalism are the women. Okay? So science teaches us to unify. Okay. Now what is boundary? It is real or imaginary line which separates a system and surroundings. Is called boundary. Say it is a star. We cannot put a line across it because we will not be able to reach there. And even if you reach, it is so vast, it's not possible to separate with a fencing. Okay? But if it is a cup of tea or coffee, see here, tea is there, and outside you have it air. But this is the boundary of the cup which separates. So it is real, and this is imaginary boundary. Done? Huh?
Yes,
What
sir.
happened? Then why you are keeping quiet? Huh? Everybody thinks that others will tell, huh? Okay. Now classification of system. Classification of system. Now I'll draw some system. My drawing is very bad, huh? Don't laugh. See here. Acha, how do you know? Say this is that. Acha, how do you know from outside that this cup contains a hot liquid, tea, or suppose you are drawing it? How the people who are watching your drawing can understand that this contains a hot cup of tea or coffee? How? After that, will you draw something?
The steam
How do you
sense.
indicate? Huh? Yes,
Steam.
yes. That is, in that case, what we'll do? We'll draw like. And if you keep it for some time, it will get cold. Is it not? Oh. Now, see here. You know, what is this I have drawn? Huh? What is this?
Pressure cooker.
Really? I think my drawing is not that bad. Okay. Now, yes. Okay, like this, and say it is having a belt also like this. Huh? Like this. All right, and you can keep both hot liquid or you can keep on ice also. So what is this?
It's a flask.
Yes. See here, what are the differences there? So in pressure cooker, until and unless this whistle is there, nothing goes out from there if your pressure cooker is perfect. See here, in this case, what happens? Both heat and I write matter, okay? Matter can escape. In this case, what happens? Only heat can or escape, not the matter. Because when you cook rice, your rice doesn't jump out of it. Okay, when you cool it, nothing from outside can enter. And in this case, what happens? Neither heat or matter can leave or enter. So these are the three types of system. All right. So this is called open system. See, most of the thing in this universe is open system. Most of the thing that you find in our nature, open system. This is what This is called closed system. And what is this? This is an isolated or insulated system. So we have three types of systems. All right. So I'll rub it and write down. So after you finishing, then if you have time, then you can draw. So all of you understood now that there can be three types of systems: open system, closed system, and isolated or insulated. Okay, so I'll write down here. Open system. A system which can exchange matter as well as energy with the surroundings is called open system. See, it's not that I've shown you hot cup of coffee. In hot cup of coffee, heat from inside will go outside, and the water will go outside in the form of vapor. Okay. Now, second example I can give you where and here I kept some ice cube like this. Like this. Okay. So what will happen if I keep it after some time? Hello?
It will melt.
Yes. Means what? Heat from outside has come inside. And very interesting, you will see, you did not disturb it. But you'll find inside this inner wall of the beaker, droplets of water has formed. But your ice water did not go up. Far from the vapor, this liquid has come because the water vapor which was around this, it has entered and got condensed. So in an open system, as the matter can go out, as the heat or energy can go out, similarly to the surroundings, similarly from surroundings, heat can enter along with the matter. Okay. So example, what you can write? Example, a cup of hot tea, or a coffee spelling is COFF or COFFE.
COFFE.
Acha. Very good. Because I don't like take coffee, so for spelling also I forget. Okay, now closed system. a system which can exchange energy and not the matter with the surroundings is called closed system. Okay, so I thought I can write an example. Hot coffee in a stainless steel flask. You know, metals conduct heat. So this is this one. Now, third, isolated or insulated system. A system which can neither exchange energy or matter with the surroundings is called an isolated or insulated system. Example, thermoflask. बहुत देखते लगे तो बताओ note, this is for entrance. All physical and chemical processes taking place in universe are open systems because they continuously exchange matter and energy with the surroundings. Okay. So now we are going to discuss something about the properties. Huh? See, we cannot discuss the property of atoms and molecules. So we are going to, in thermodynamics, see, this is the limitation. Thermodynamics does not deal with the smaller things. It deals with the large amount of things. So large amount of things are called macroscopic system. Okay. So let us write here now macroscopic properties of the system. This is B. Macroscopic properties of the system. It is classified into two categories. Okay, one. Extensive properties. And second, intensive properties. See here, what is extensive properties? Those properties which depends upon the amount of the system. Okay, see, if I've taken a small amount, so this will be the volume. If I have taken a large amount, so this will be the volume. So in that case, the properties which depends upon the amount of the substance present are called extensive properties. Okay. So now we'll go for extensive properties. The properties of the system whose value তুমি একটু বাইরে গেলে একেবারে আমার কনফারের বোধ একটু গেটের সময় যাও দুইবার কনফারেন্সে হ্যাঁ whose value depend upon the amount or size of the substance present in the system are called extensive properties. Okay, now see what are the extensive property? If the amount of substance is more, its mass will be more. So example is what? Mass. Then volume. Then surface area. Okay. Then then I'll write heat. See, suppose you are going to make tea for you and your mother. You take less amount of water, it takes less time to boil. But suppose you want to make it for 10 persons, you have to take more amount of water, so volume of water is more, and you have to supply more. It takes long time to boil, so heat is required more. Okay. Then these are the ones still you are yet to know, so I'll discuss later on. Internal energy, enthalpy. Okay, see, heat and enthalpy is same. So, okay, I'll remove enthalpy. No, I'll write both. Enthalpy, then free energy. Sorry, I'll write now here entropy, free energy. All these things I'll discuss with you in detail. Free energy, heat, capacity, etc. Now I'll go for. It will take around one more day to finish. Achha, by the way, I want to tell you, I'll be taking an extra class on this Sunday because I have already lost 3 or 4 classes with you. And in thermodynamics, I have to explain each and every term, and I have to write a lot. Because if I tell and you know, do understand. I'll be sending note also, I told you. So in that case, this Sunday, I'll not make it 7:30, I'll make it 8 o'clock. I'll take 1 hour class. Okay. And Ajalia is going to call me at 7:30 if I forget. Hello, Ajalia. Hello. Ajalia is there. Huh? What happened? Intensive property. So if Ajalia is not there, then Najia will call me. Najia? The properties of the system whose value is independent of the amount or size of the system. Are called intensive property. See, example, whatever amount of water I take, whether I take 10 ml or 10 liter, boiling point of water is 100 degrees Celsius. Heat requirement will be different. So heat is an extensive property, but both of them are going to boil at 100 degrees Celsius. So it is irrespective of the amount of the substance taken. So example, temperature. Pressure. Pressure is always unit volume. Density. Viscosity. Surface tension. Specific heat. Always find for 1 gram. Okay.
So what did you wrote after density?
After density is viscosity, surface tension, specific heat capacity, vapor, pressure. Refractive index. Etc. Okay. So today I finish here. So I'll be meeting you Sunday at 8 o'clock.
Thank you, sir.
Thank you.
Thank you, sir.
And you remind me at 7:30.
আগে ওখান থেকে একটা একটা নিয়ে এলে কি হয়, তাহলে আর বেশি কিনতে লাগে না। এটা দিয়ে একটা 1400 কিনতে গিয়ে দেখবে 20 টাকা লেগে গেছে, 20-30 টাকা।
লাগবে যখন 30 টাকা। না আমি অত না, একটাই খালি একটু মুখবো আর বাকি খালি একটা টাকা।
কিচ্ছু কিনতে লাগবে না তোমার,
কিচ্ছু কিনতে হবে না।
14টা হয় তোমার কিচ্ছু কিনতে হবে না, কারণ পালং আছে, স্কোয়াশের 2-3টা পাতা নিলে, কুমড়া 2-3টা পাতা নিলে শাক এমনি হয়ে যাবে।
পালং কই আসছে?
পালং উঠেছে না আমাদের।
ও হ্যাঁ,
কিচ্ছু কিনতে লাগবে না, তুমি খালি কলটা খুলে এসো, দেখো আছে কি।